Okay, hello folks. Just to make sure you're in the right place, this is about Apache Atlas, not the other session. And this is, I've had a few talks today, so forgive me if my voice is starting to go. Because of that, if you want to ask questions, go right ahead, I'll let you. We're going to talk about Apache Atlas Tracking dataset lineage across Hadoop components. This is going to be pretty informal. I'm going to talk about one of the big areas in terms of differentiators for the Hadoop Hortonworks. We have this cross-component lineage capability. And what we'll do is we'll give you a little bit of a peek into it. We'll talk about how we track it, what it looks like in the interface. I'll show you the tutorial that we have online and give you some resources there, right? But let's keep this interactive. If you have a question, if it's going to be perhaps a more detailed answer, perhaps we can table that. But if it's a quick answer, and it's obviously adds to the discussion, please ask it. Okay. All right, we'll get started. That's me. I cover the governance products for Hortonworks. I'm the product manager for Apache Atlas. I also run a program called the Data Governance Initiative. I think some of you may have heard this twice already today. So if you have any questions about that, I can talk to it. In a former life, I worked at the NYC Euronext, obviously heavily regulated industry. So I have a little bit of experience with regulated environments and lots of different compliance scenarios. All right, so let's get started. So here's what we're going to talk about. I'm just going to give you a quick overview. For those of you who are on the third session for Atlas today, thank you very much. I appreciate it. I'll try to make it quick and minimally painful. We'll talk about the near-term roadmap. And there are three big items there, and we'll obviously be talking about cross-component lineage in that one. And then we'll have time for more questions, right? So this is our fancy new animated graphic, but really it's to talk about how we want to make sure that Atlas really fits into the larger governance picture in your enterprise. We want to make sure that it adheres to all the rigors, the requirements that all the other platforms do, right? And so things like transparency, reproducibility, auditability, and consistency, these are things that those other platforms must provide. Hadoop is no different. And in order to use it effectively in a data lake, with multi-tenants, lots of data from different silos, you need to make sure you have those types of programs in place, right? So one of the things that we will providing through Atlas is data management, modeling, and the interoperable solutions. This is kind of a high-level bucketing of the services that we provide, right? A little bit about DGI. DGI is a data governance initiative, and it started off with a group of customers that were, fairly along in their Hadoop journey. So typically, folks start off with a POC or a proof of technology, and they will perhaps deploy a very specific point solution. So it's essentially the same POC, but just at a larger scale. And typically, it's for a type of problem that is not easily solved by the existing tool set, right? So that's typically how it goes. Once they find value in that solution, they want to go to that next step. That third step is the data lake, where you have multi-tenancy, you have silos from different lines of business, data that may not have been commingled ever before, right? You need this to get new insights and to get these types of advantages from that analysis. So that's why you put it together, obviously. But you also are introducing new kinds of problems. And really, those new kinds of problems occur when you get to that third state. And these folks that you see on the screen, and you can figure out who the global financial company is by looking at Apache website. All committers are there. I just can't name them now. but we worked together with them to build out a set of capabilities. And so unlike a lot of other projects that kind of grow organically in ASF, we were able to create one that was really a co-development effort. So we actually built the product around capabilities that were required. So if you were here for the earlier session where we talked about tag-based policy, that's specifically from a pharmaceutical company that is multinational, and they needed to have these dynamic policies around, certain types of tag-based policies, geography-based policies, time-based policies, and prohibition. That was specifically out of their requirements. So the advantage there really is instead of having, a proprietary or a custom solution which requires lots of support, they were able to actually, take that work, those use cases, and you really contribute back to the project, right? Because a lot of other people have similar challenges, right? And that's really the idea around the co-development effort around DGI, right? Started in December, basically had the foundation, the first release in July. That's really for more of a technical customer. It was not easy to consume. It required quite a bit of coding to get good value out of it. I think this next release, the .6 release, is going to be something that is quite a bit more accessible and has a lot more enterprise readiness involved. And we can talk about that in a little bit of detail when we talk about the architecture. Right. Questions? Okay. All right, so what does Atlas provide? Well, what we really want to do with Atlas, as I mentioned earlier, is to provide that continuity, to be able to use metadata to really orchestrate and bring rationality to all the different components within Hadoop, right? You're not going to use one component to do your job, right? You're going to use many. And that complexity can cause some problems, right? You want to typically get a service done, not be a Hadoop expert, right? So, realizing that we wanted to bring more rigor around getting these types of activities done. So, we created Atlas, right? And Atlas is really about metadata. We don't want to recreate functionality that's already in the Hadoop stack. We really want to just orchestrate it. And so we use metadata to track dataset lineage across those components you see up there, as well as providing a nice entry point to integrate outside of Hadoop, right? So Atlas is really trying to be the metadata truth in Hadoop and then connect to other systems, if they're willing to exchange metadata information, right? Some are more willing than others. The early release that we had back in July, was Hive integration. So anything you did in Hive, we automatically track that. In this coming release, in the summer, we will have Scoop, Storm, Kafka, Ranger, Falcon. So Scoop, connecting, pulling data and pushing data into relational sources. Storm for stream processing. Kafka for messaging. Ranger, that's integration for security purposes, and then Falcon for data lifecycle management, right? So all of those things now are going to be tracked through Atlas. So we have a native connector, right, that's on the component side that will actually talk to Atlas and report activity, right? You don't have to do this. You don't have to build a custom report. That's already set up for you, right?
Plug-in type thing?
Say again?
Plug-in type thing on the component side?
Yeah, it is a plugin type of thing. We have a notification framework, so we actually use messaging in between. So it's not exactly a plugin, but yeah, logically speaking, it is that way. Right.
Why is Spark and Wi-Fi different color? Is that yet to come? Or?
That's exactly the reason why. Thank you. Spark is going to be coming towards the end of this year. We will have it by the year's end. We'll also have Wi-Fi. This is a bit conservative. There'll probably be at least 2 more components that we add. We just haven't decided which one we're going to stick in yet. There's a very good chance HBase will be in there, and accordingly, probably Phoenix, right? There's probably going to be one other one, which I don't want to mention yet. But the 2 that we will definitely have in there is Spark and Wi-Fi. Absolutely. Okay. Well, they're having quite a bit of fun over there. Management scalability. So the purpose of doing all of this stuff, obviously, is to get scalability, right? So you have a lot of traditional tools and patterns to manage traditional data warehouses, and they don't necessarily translate really well into Hadoop. And really what we want to do is give you more tools. We don't want to take away things. You can still do the things the way you have been, but you need to have some additional tools, and that's really what we want to provide here. So we feel that the way to do that is to leverage metadata and specifically tags for management, discovery, and security. Right? Kind of talked about this earlier if you were in the earlier sessions. Okay, high-level architecture. We'll talk about this a little bit more than we have in the past. So this is kind of interesting in the way it's set up. And for those of you who have already heard this part, apologies there. The first thing I want to start with was this thing right here called the type system. It's powered by a graph database. It's TitanDB. The backing store for that is HBase. And the reason why we picked that is it really excels in building relationships, right? So one of the things that we want to do is have very agile modeling capabilities. So you can define a brand new data type that doesn't exist. Like you can build a custom one for yourself, right? We've already built one for all the connectors that we have, but you can build another one if you like. You can build a logical one, right? And this is, we had a little talk about this earlier today in the other session about business catalog, where we're able to have conceptual, logical, and physical objects that we can all relate together. And we can build them in a hierarchical structure, right? So that's basically made possible by using a graph database. And the reason why we did that is we can easily create new relationships. So if you import whole metadata structures, let's say your company bought another company and they model customer differently, well, you typically have a problem. But because we're flexible, we can actually create a parent or a child relationship or create another entity and relate them down, right? A supertype, if you will, right? So you have that flexibility. Consequently, if you have a reporting structure and you have a taxonomy you want to use, maybe it's a Cord, or maybe you're an energy company, you use PPDM or CWM, whatever you like, you can build that metadata structure in Atlas, so when the data goes into your data lake, it'll be tagged with the correct taxonomy, so you do your reporting, and you have easy compliance, right? So these are all the things that are made possible with very easy and agile data modeling, right? Obviously, if you have a downstream system that you need to park data in or metadata in, you can obviously align them, right? Talked about this area here, the messaging framework. By the way, this is in gray, and that's in gray, because those are subcomponents that Atlas depends upon. So the messaging framework is a Kafka quorum. The repository is HBase. And search is a Solar Cloud. So you can see that these are mature components. There's a lot of practices around building a really robust deployment. You may already have these already, so you can just leverage them, right? But the idea here is all the things that the Atlas service depends on are already very highly reliable and scalable, right? So the messaging framework, the reason why we use that, and we introduced that in this release, .6, is because the graph database can kind of get backed up if you have quite a bit of activity. When you create a lot of new objects and relationships, it can get backed up a bit. So we use a notification framework to make sure that we can handle those peak loads. And also for reliability, right? So if one side of that communication breaks, it can recover, and we have message durability, so we can just read the messages and replay them, right? Mention that everything is built in a hierarchical structure. So actually, if you replay messages, it will not duplicate them, right? Because we have a very strict context. So it will not allow you to create a duplicate. Okay, we have another thing here called the bridge, and I'll talk about that in the next slide. But basically, that is kind of part of our kind of design pattern for all the hooks, and we'll talk about that later. And then the connectors are really going to be also called connectors are called hooks, and there's a reason why, and I'll talk about that in a second. Let's see, REST APIs. Obviously, you guys know what that is. If you want to build a custom connector, you can do it through the REST APIs. Anything you can do in the UI, you can do through the APIs as well. So programmatically, you can have pretty easy integration. All the stuff is Apache 2.0. You can take part or all of it and use it in any way you like, actually. You can actually resell it quite easily. Near-term roadmap. So as I talked about this earlier, dynamic policies. This is a tag-based policy. This is kind of unique to us. This is it's quite significant. I don't want to diminish it, even though I'm really tired and my throat is a little sore. But this is very important. This is something nobody else has. And if you were at the early session, you got most of that. If you have questions on this, we can talk about this at a later time. Business catalog, we talked about this in also an earlier session today. And that's where we are basically getting that model of having conceptual, logical, and physical relationships built with that hierarchy, right? But we're going to talk about cross-component lineage in this session, right? So in this new release, we have all these different components that we're going to be able to automatically track lineage for, right? So we have the custom stuff through the APIs. We have Scoop, but because things are like right on top of Scoop, so anything that is leveraging Scoop, we actually get lineage automatically too, such as Teradata Connector. Storm has a Kafka bolt, so if you use that route to get in get your stream processing, we track that as well. And then we have Falcon and Hive, and we actually track lineage going back and forth across them. So this cross-component lineage is actually very unique in that there's no other product that can currently do this set, right? Especially the streaming part right here. So we're going to expand this, obviously, with Spark and NiFi and probably HBase by the end of the year. So this is just going to expand. So whatever you do in terms of deployment, you'll just inherit more connectors as we go forward. And we've got a pretty good plan in terms of getting a complete package. I think Hive was obviously the big one that we had to have, but we're going to get we'll probably get the lion's share of them done this year, and there'll be maybe a few stragglers next year, right? Okay, so you typically want to get metadata with your data from outside of Hadoop, and this basically just illustrates how that works, right? So we want to make sure we capture the metadata payload. So remember, we got to the third state of Hadoop adoption, that data lake. Well, this is when it's really important, right? When you start having a lot of different systems putting data into your data lake, you really need to have, you need to capture that metadata, right? You want to maintain the maximum fidelity of that metadata as close to the source as possible, right? Okay. So we're just going to take a look at the Hive integration kind of as a model to see how it works. So we have a thing called a bridge. I talked about it earlier. And basically, this is kind of a bootstrapping operation. It's a bit costly, so you have to be careful when you run it. And as I mentioned, because we have a notion of a context, there will be no duplication. So you would run this in situations where you have a business continuity situation where you need to bring up a DR scenario, or if you're doing an upgrade, you might want to back something up. Or you're having a fresh install and you want to just basically extract everything that's currently in Hive, let's say, right? Now, once you've done that, which is a very expensive operation, you want something kind of light, right? And that's what the hook is. The hook is the connector. So all the activity that's done in Hive gets reported to Atlas, right? And it's done post-execution. It's very important why we do it post-execution. So Ranger is taking care of the security audits before execution, right? But once it goes into Hive, we don't want to mess with it, right? We want to make sure that it's as fast as it can be and as reliable as it can be, right? So we let whatever that's going to happen because it's already been authorized by Ranger. And once it's done, we actually have more metadata because now we know if that query was successful. We know how long it took, that kind of stuff. And we are able to capture that with the metadata object inside of Atlas, right? Later this year, we're going to have NiFi integration. So the integration is pretty cool. You know all the wonderful things that NiFi can do. But one of the things that is difficult is it's hard to keep lineage for very long. We can keep it for years, right? And we can do that effectively because we don't need to keep the maximum fidelity that NiFi natively keeps. They do a lot of caching that we don't need to keep for lineage purposes, right? So we can streamline that and we're able to be more effective about that. Consequently, we can give NiFi an authoritative taxonomy. So when they do their processing at the event level, they're using the proper reference, right? And this is true for basically all the platforms that we connect to. We want to make sure they're using our tags, so we only have it in one place, right? We also have this, oh, I took that demo out. I took that slide out. But obviously, NiFi has many clusters that you can deploy, but somehow that data needs to be reconciled, the metadata from those different clusters, and we can do that in Atlas. You can have many NiFi clusters feeding into Atlas, right?
What's the approach for, what will be the approach for keeping and persisting the NiFi metadata? touch data, do that separately?
Yeah, so basically, after this window, we're going to keep the design time metadata in Atlas, right, and all the changes that have occurred. But what about, as you mentioned, the event level? Well, event's hard because it's, you have to have some way of parsing out a block of them, right? So NiFi has a way of doing that. So what we're going to do is keep that data in HDFS. We will point back to it and we'll know where it is. So you can go to the logical pointer to it, understand what it's all about, see the lineage. But if you want to actually dig down into the logs and find out what happened at a very specific time, and for any length of period you wish, we'll point you to the logs.
And that
Right.
pointer will be in Atlas.
Correct. Yep. Okay. So let's do a quick little demo. So one of the things that we have. Oh, I think I put this out of sequence. Sorry about that. At the end of this, presentation, which I think is going to be available online, if not, just let me know. I can take care of it. We have a VM you can download. We have the tutorials in Git. We have a blog that kind of talks about that, and we have more stuff on our landing page, which has been updated. Right. So this is a technical preview. It's not our official sandbox. I want to be very clear about that. This is .6. We'll have another technical preview probably at the end of May, and that will have the business catalog stuff, which we talked about in the last session. The things that deal with cross-component lineage, that is pretty stable. There's a few things we're still buttoning up. We're going to commit some more things to the trunk regarding certain types of actions in Hive. We need to be a little bit more careful about the way we manage them and version them, right? So, question there, sir.
Yeah, I work for banks, so compliance is a big issue for us, and Atlas does seem like the perfect tool to actually have our tag-based or meta-based
Sure.
compliance. However, what we did see in the previous Hadoop Apache projects, such as Ranger, is that it offers a lot of great features, a lot of cool stuff, but security itself and high availability itself is quite lacking. For instance, I can point out multiple security issues within within Ranger itself, where it gives out plain text passwords throughout the API and stuff. How in the earlier releases is high available and or secure by using Kerberos, LF connection, that kind of stuff?
Yeah, so we actually have a Ranger plugin, and those concerns that you had in early releases of Ranger have been fixed. So as I mentioned earlier, we don't want to recreate the wheel. So we actually have a Ranger plugin. So all the authentication is actually done through Ranger. The communication is encrypted. It's an SSL connection.
Ranger provides policies based on Atlas, but is Atlas also actively using a Ranger plugin or something?
The Ranger plugin is for authorization and authentication and authorization. Right, so Ranger has a capability to connect to Active Directory or some other enterprise-wide LDAP solution. We don't want to build another one of those. What a disaster, right? So what we want to do is just use the Ranger plugin. So basically, when you see users and groups, they're really pulled from Ranger, which is then pulling them from Atlas, right? From AD. And the reason why we do that is obvious, right? So if you have a situation where you need to make a change, we can do it quickly. Right, and it'll cascade down. The other thing is that we want to also centralize access auditing, right? So access and actions that occur in Atlas actually get reported to Ranger, and Ranger sees them, right? And it's the right solution.
Yeah,
right?
Is, but high availability is already been.
So high availability, it's a good question. So that global financial bank that was listed earlier, we work with them quite a bit to build out use cases. So we don't have active capabilities now, if that's your question. We have active passive. A lot of it has to do with the way cluster names are managed right now. So it's actually not a limitation in Atlas. It's actually a limitation that we need to address in Embari. So all objects have a fully qualified name in Atlas and has cluster in it, right? The cluster name. So we need to make sure that that's authoritative. We also can't have a situation where a cluster has the same name, because that will cause a lot of problems. As I mentioned, we have this notion of context. So if you have a cluster with the same name and reports similar activity, it could get dropped because it thinks it's a dupe. So we got to arbitrate that. We are going to fix it for the next release. By the end of the year, we will actually have active-active, multi-cluster aware. It's also for hybrid solutions where you have on-prem and cloud solutions. That's a particular problem that a lot of folks are facing. So how do you address that? You want to have one metadata solution. If you move data around locally, then you push it up to some cloud instance. Well, it's still your data. It's still your same workflow. You need to know where it is. So the location should be immaterial. You should be able to track it wherever it is. So that's something that we're working on too. So that solution for that second cluster will help us solve that cloud hybrid solution. All right, so this is a tutorial on a technical preview, right? So just throwing it out there, right? So we're refining this. We'll have another one that's much better at the end of the month, and then you'll have the GA version in the summertime, right? Now, having said that, the DGI members, the data governance members who help kind of spawn the project itself, have had quite a bit of this, the bits, since December. So that's one of the advantages they have, right? So this is the first technical preview, a public technical preview. Okay, all right, where is that? Okay, so let me give you a quick tour of Atlas. So this is, oh, I hope this is gonna work for me here. My VM died. Okay, excuse me. Let's see. Ah, lovely. Okay, this may take a while. Okay, I went to sleep. Apologies there. But the VM is in S3, and actually, you can pull it down in a reasonable amount of time. Anywhere from 10 to 20 minutes is pretty typical, even here. So it's pretty straightforward. Once you get it, which you're going to see me do, it's going to take a little while for the services to start. Actually, I should probably reboot this. Let me see if it's good. Huh. Top secret password. Okay, so if this is not all green, just come down here and just hit, start all. I'm gonna hope this is gonna work because it was sleeping. So it's so all these ports and everything are listed in the tutorial that I'll share with you.
Top of your web browser is not displaying.
So say again?
Top of your web browser is not displaying.
Oh, wow, that's strange. Okay, is that better?
Just pull it down.
Okay. Alrighty. Okay, this is going to be interesting. Okay, so I want to give you a tour of Atlas. So there's a lot of things to show you, but let's start at Atlas. So this is the prototype UI. Okay, the new UI is actually quite a bit nicer, and it will be in May. But this is the prototype. So we can support keywords or the DSL. So we can do things like, let's say we want to see all the Hive processes that we've been looking at. So this is every select that anybody's have done. So this is working. I just wanted to check to make sure it's working. We have this notion of tags, and this is kind of orthogonal to the other hierarchy, right? So they kind of intersect. So something like PII can be in both like an HR context as well as a finance context, right? So that's why we keep these two different structures, right? So you can search through our graph database for tags, right? So it looks like there was a Hive column, it had location, it's an employee location ERP, right? We can also search by expires on. This is another thing from the earlier part of our talks. It has to do with a policy that governs expiry, a data lease, right? But you can also do things like search for Hive tables. Let's see what we've got here. So you can see all the different Hive tables that we have here. And one of the things you can do is you can go ahead and define a tag for it at this level, right? You can also do something fun, like go into a table itself. Showing okay? All right, good. And you can get the lineage of that object. Wow, this resolution is not great. But you can see that we're actually, this is a live graph here, so you can actually get information about what's been occurring. There was a create table, looks like it was a CTAS operation. I created a new employee, right? You can size this, move it around to your heart's content. We also track some attributes. We have quite a bit of attributes that we track, but this is just a small subset. Maybe I can do this. Is that better? Nope, does not help at all. Okay. Let's move that up. This is strange. Why is this not moving? So as you can see, we track different attributes. So we have value, the database, the owner. So this is stuff that we normally track quite easily, so you don't have to do anything here. This is configurable. You can do it with an XML file. We also dynamically track schema. Wow, this is not working out. Well, okay, so there's just there's only two columns here, name and ID. But if we wanted to, we could even tag at the column level. We can tag that data producer, right? And so the point I want to show you here is now you can, because of the way we modeled it, you can define and tag a data element in Hive, for instance, at a column level, right? File obviously is the whole file, but you can do a table and database, but you can go down to the column level. We'll have more specificity in terms of controlling or access to rows and columns dynamically. Probably by the end of the year, we might have a nice preview by summertime where we have dynamic row level filtering and column level filtering and masking, right? Okay. So that's a quick tour of Apache Atlas here. Let me go back. Now, if you look in the tutorial, which I brought up for you, can you read that? Oh, it actually looks pretty good. So this is what you'll get. There's actually two tutorials. One of them is the tag-based policy, and this is the other one, which is cross-component. And we're only doing 2 items here, but this is just illustrative of what you can do. So you get the VM. It'll walk you through all the steps. And basically, we're going to use Scoop to go grab a table and put it into Hive. We create the table, run the Scoop job. So it's actually pretty well written. I think it'll be pretty self-explanatory. And then you can create a further CTAS operation, and that lineage will automatically be tracked. So if we look at Hive table, I think you can do it a couple of ways. I think the Hive table here is, I think it's this one. So we get the lineage. There's my SQL job. This was a report that some activity was done in MySQL, but we track that anyway. It's a custom report. This Scoop operation was performed. Get the details. This was landed in Hive. There was a create table afterwards, so we created some lineage, and now there is the product of that. So we're tracking all of that, right, dynamically. You didn't have to do anything to create that.
Sorry, did you say you're tracking it already in MySQL before it came in?
Well, the operation that we did a custom reporting. Right, so we basically had a shell script that did the MySQL work. At the end of it, reported through our custom, through our API, through a custom reporter. Right, should have mentioned that. Been a little more clear. Okay, so we can also look for things that relate to Scoop, right? So you can see what happened, right? There's a Scoop process, and this is what it did, and you get all the wonderful gory details, right? Now, if you go through the tutorial, we'll actually go through a storm topology as well, right? So we start off, you create the topic, and then you do all these different steps, and then you actually go run that topology, right? So there, we can look for a type called Kafka. I think it's called Kafka topic. Notice that Kafka is modeled differently than a database. They have topics. They don't have tables or databases in Kafka, obviously. So it's modeled differently, so it has a different type, the naming structure, right? But you can get information about that, and you can dig down into it, and you get how it came to be. You get that lineage, right? So we're able to track lineage from that. You can also tag here, right? Get the same window. Right? You can also see storm assets, right? So you can see the storm bolts or the different data sets that were used. And as I mentioned, you can walk through this stuff, and it will actually spawn another search. So as you can see, I'm not going to bore you with all the different connectors because we have a lot now, but it works. We have native connectors. They go through our notification framework, and they get reported to Atlas. So this is kind of a watershed moment. We'll have a much bigger demo / tutorial built in a little bit with the new UI, where we're going to tie more of it together, and we'll kind of squeeze in Ranger as well to kind of visualize it a little bit better. Got to have some kind of nice visualization tool. That'll be coming, but this is quite usable now. So if you are using any of those components, feel free to download the VM and exercise it. That's something that's available to you now, right? And that's all of the tour that I had prepared. Was there any other questions you guys had we could talk about? We've got about 4 minutes. Well, 4 minutes to the green light, and then I think the red light means 5 more minutes. So I guess we have 8 minutes or so. Yeah.
So until you get the HBase or the Spark connectors, are you able to kind of push your own metadata to the API?
So say again, are you able to push?
The HBase and the Spark connectors, can you push your own metadata through the API to represent that?
Absolutely.
Yeah.
Yep. In fact, that's the way we envisioned most of the connections to be done when we first released it, and we realized that was a little bit too much housekeeping for most of the customers. Not that they couldn't do it because they didn't want to maintain that, but absolutely you could do that, right? One of the things that you may do is have the data itself, the payload, go into Hadoop, but you may keep your metadata somewhere else, and that can have a totally different structure. Sometimes, many workflows will have the metadata encapsulated into like a manifest file. So you want to keep it together perhaps. So that kind of thing can be easily scriptable, right? So you don't have to break your current flow. That's really what we want to do. We don't want you to have to change the way you do things. We want to just give you more tools to manage them better. Right. Was there a question back there? Yes, sir.
Talk to the start about having types and hierarchies of types.
Yes.
The demo just shows simple tags. Is that something that's on the roadmap to be able to assign?
Sorry, say again?
Well, what I got from that was that you'd be able to construct, say, a more complex type that incorporates a hierarchy of different tags.
Yeah, so the way it's implemented in our type system, both business terms and tags are represented as traits. I don't know if you've been looking at our source code, but that's the way they're represented. However, we have a slew of new APIs that treat them a little differently. So now we're making more of a distinction. So while you can have a hierarchy of tags and a hierarchy of your business terms, we recommend that you don't go too deep with the tags. And the reason why is when we deploy inheritance, it's going to cause a problem if you have too much inheritance on two different models that overlap and get related to an instantiated entity, right? 'Cause that causes all kinds of problems. So one of the things we worked really hard for was versioning, and we need to kind of trace back and traverse all the edges, right, to be able to properly snapshot and version these events over time. And if we have too many hierarchies, it can actually cause conflicts and cause all kinds of problems. So to answer your question in a very roundabout, long way, we can do both, but we recommend that you have kind of a flat tag structure, and you can go as deep as you want with the business taxonomy. Okay. Another question. Yes, sir.
Is it possible to see the lineage of all columns in one graph?
All the columns in one graph. You're a very good customer, so I will do my best to answer you, sir. You stuck it out for all the sessions. I really appreciate that. Column level lineage is not available in this preview and will not be available in summer. It will be available by the end of the year. Yes. And before you ask, we don't support select statements at this time. We're working on it. It's kind of a hard problem to solve. Being very honest and transparent there. Other questions? Oh, time is up. I got the hook. It says 11 seconds here. Thank you very much for sticking it out and coming to my session. I really appreciate it. If you have questions, please feel free to ask. I'll be around. Thank you very much.